So hello everybody. So I will present you my master thesis about dry matter and protein apparent digestibility of different ingredients at two dietary level in diet for Litopenaeus, vannamei, Juvenile. So as you can see in this graphic, so the world of food is rising and aquaculture has expanded faster in recent decades than any other livestock sectors.
Sorry, I don't see the presentation. I see you, but not the presentation.
I go back?
Yeah, because I don't see your slide.
Okay. I can try to share again.
Yeah. Carlo, do you see your slides?
No. You have to try to share the screen again.
I will share it again.
Rodrigo, are you around? I think everybody was okay. Now it's fine.
Okay. Now it's fine?
Yeah.
Okay, I'm sorry.
Perhaps start again, so if you don't mind, Yann.
Yeah, okay. So I will present my thesis work about dry matter and protein apparent digestibility of different ingredients at two dietary level in diet for Litopenaeus, vannamei, Juvenile. So as you can see in this graphic, so the worldwide demand for seafood is rising and aquaculture has expanded faster in recent decades than any other livestock sector. And shrimp aquaculture is in the second rank of the most traded product in terms of value. And Litopenaeus vannamei, also called the American whiteleg shrimp, is the main cultivated shrimp species worldwide. So why? Because it's fast growth, it's easy to culture at very high density, it's tolerant to a wide range of salinity, and it requires a lower protein feed than other species, and it's resistant to various diseases. And so the feed represents 40 to 60% of the production cost in the shrimp farm. And so the characteristic of a good aqua feed, so it must contain all the essential nutrients for the cultured organism, be highly digestible, and have adequate organoleptic property, so attractability and palatability, and physical properties such as hydrostability and particle size. And so the protein is required in shrimp feed and is a major and expensive nutrient. And so the fish meal has been the most important feedstuff used as a source of protein in aquaculture diet. But the soybean and white meal are also commonly used. So the soybean, because of its balanced amino acid profile, consistent composition, and worldwide availability and low cost. And the white meal is mainly used as energy sources, binder, and fiber. And the balanced feed must have a good digestibility to efficiently cover the nutrition requirement of the organism. So the digestibility, it's a measure of the degree of net absorption of nutrients in the digestive tract of an organism. And the apparent digestibility coefficient correspond to the fraction of ingested food that is not found in the feces. And to evaluate it, in the ingredients, the most common method employed, it's a reference diet and a test diet, which contains the reference diet at 70% and the experimental ingredient at 30%. But different proportion of the reference diet and the experimental ingredient have also been used, such as 85% and 15%, to avoid nutritional imbalance of the experimental diet, which can affect the digestibility. And here we have a work of Carvalho et al. And they found that the apparent digestibility coefficient of several test ingredients were significantly affected by the ingredient type and the dietary level. So the hypothesis of my thesis is that the apparent digestibility of dry matter and protein of common feedstuff used as in aquafeed, like fish meal, soy protein, and wet meal, will be different because of the quality of the raw material, their different chemical composition, and or processing used, among other, but also by the inclusion level in diet for the shrimp. And the objective, so the first part was to determine the apparent dry matter and protein digestibility of fish meal, soybean protein, and wheat meal at two inclusion levels, so 15% and 30% in diet for the shrimp. But the second part couldn't be done because of the COVID situation, but it was to evaluate the microbiota of the digestive tract of the Litopenaeus vannamei juvenile before and after being fed a diet containing fish meal, soybean protein, and white meal at two dietary level. So now material and method. So in the first table, we can see the ingredient composition of the reference diet, which was formulated to contain 27% of crude protein, around 6% of lipid, and 1% of chromic oxide, which is an inert marker. And in the second table is the composition of the test diet. So the FM15, which is the fish meal at 15%, and which 85% of the reference diet, and the fish meal at 30%, which with 70% of the reference diet, and the same for the soybean protein and the wheat meal. And here we have the different steps of the diet preparation. So first was the pulverization of the ingredient, then the homogenization, and after the extrusion in a meat grinder. And then the pellets that we obtain are drying in an oven at 45 degrees for 12 hours until reaching a moisture content of around 10%. We also did a water stability test, which was estimated by dry matter weight loss of pellet in seawater, so according to the method of Obaldo et al. And so the Litopenaeus vannamei post-larvae were obtained from a commercial hatchery and then transported and acclimated to the aquatic nutrition laboratory at the Sibnor and grown to the desired rate in this big tank. So in this picture, you can see the culture system. And here we have the different culture conditions. So the temperature at 27, salinity at 40, the dissolved oxygen at 5, photo period at 12. The shrimp weight was between 7 and 8.6 gram. And the density was 8 organisms per tank. There was 7 different diets with 3 replicate. And so the duration was 28 days. And there was 1 week of acclimatation before the feces collection. And the feeding was 3 times a day. And the feces collection 2 times a day. And here you can see how we proceed for the feces collection with the help of a plastic hose. And then, so there was a proximate composition. So the ingredient and diet were analyzed in triplicate to measure the moisture, ash, crude protein, ether extract, crude fiber, and the nitrogen free extract content according to the IMBRSea method. And feces were analyzed for protein. And for the chromic oxide, so which was an inert marker, so the diet and feces were analyzed in triplicate according to the Fukuoka and Tsurukawa method. And here we have the digestibility calculation. So the first one for the dry matter and protein of each diet, according to the method of Cho and Singer. And the second one for calculate the digestibility of the test ingredient, according to the method of Bureau and Ua. And we also did a statistical analysis. So the normality and homogeneity tests were applied on all data. So one-way ANOVA was used for the different diet, and a two-way ANOVA among the ingredients. And if significant differences existed, 2K multiple comparison of meat test was applied. And now the result and discussion. So here in this graphic, we have the result of water stability. And so we can see that it's higher than 88% for all the diet. And the less stable feed was the SP30. and the more stable the WM30. And so why it's important to have a good water stability? So because of the nutrient leaching that can modify the composition of the diet and cause error in the measure of the digestibility. And so we found adequate result comparing to the value reported by Obaldo et al. And here we have the approximate composition of the experimental meal. So for the fish meal is from Iceland. And so the low level of ash and high level of protein correspond to a meal produced with wolf fish, according to Windsor. And for the soybean protein and wheat meal, we can see they have a lower level of protein and lower level of ash. And for the soybean protein, it has higher level of crude fiber. And for the plant ingredient, the variety, crop season, and processing method are also very important to define their chemical composition. Here we have the approximate composition of the experimental diet, which reflects the content of the meal and the different level of inclusion. And here we have the dry matter and protein digestibility of the diet. So the highest dry matter ADC was found for WM30, followed by FM15, and the lowest was found for diet containing the soybean protein. And for the protein digestibility, the ADC of the diet FM30 was the lowest, and SP30 at the highest value. And so significant difference in the apparent digestibility coefficient of the test diet were detected. And the ADC for dry matter of the diet containing the fish meal are similar. However, the protein ADC of the diet FM30 was significantly lower than the diet FM15, and it could be related to the ingredient dietary inclusion level and the chemical composition of the diet. And now we have the dry matter and protein digestibility of the meal. So the dry matter apparent digestibility of the different meal was higher than 80%, except for the soybean protein, which was around 70%, and the protein the best used ingredient meal, followed by the fish meal, and the lower value obtained for the soybean protein could be explained by its higher level of crude fiber, and significant effect by the type of meal was observed. And the soybean protein and wheat meal had higher protein digestibility than fish meal. However, it must be considered that they have a lower biological value than the fish meal. And here in this table, we proceed to a two-way ANOVA. And we can see that the protein ADC of the meal are significantly affected by the type of meal, but not by the inclusion level. While for a significant interaction between the two factors was detected for the dry matter digestibility. And so to conclude, the present study demonstrates that diet containing the tested meal have a high protein digestibility, higher than 88%, which is a reflection of the high protein digestibility of the meal, and except for the fish meal include at 30% in diet. And soybean protein and wheat meal had a similar or higher protein digestibility than the fish meal used. However, fish meal containing diet had higher dry matter digestibility than those containing soybean, probably by the fiber content in soybean diet. And under our experimental condition, protein ADC of the meal is significantly affected by the type of meal, but not by the inclusion level, while a significant interaction between the two factors was detected for the dry matter digestibility. And the result obtained confirm partially our hypothesis and indicate that both factor, type of meal and nutrition level are related. And it is suggested that future digestibility studies should test both variables simultaneously to obtain accurate result. And further research will also be conducted to determine the effect of using different ingredients at various dietary level on shrimp microbiota and its relationship to nutrient digestibility. And so I would like to thank my supervisor and all the SIMNOR staff and also the IMBRSea program and my friend and my family. So thank you for listening me.